Just revise once, all of you. Any topic particularly you need, I'll explain that also. See, basically, what is the limit of a function? Okay, different functions, students. Here, see, we have limits chapter, but immediately, we discussed about the definition of function, correct? And what is the domain, and what is the codomain, and what is the range? Then what is a modulus function? How is its graph, and what is its domain and range? Because that are like important role these functions are going to play. Right? This is about modulus function and integer function. All of you clear or not about this point, students? Greatest integer function.
Yes.
What do you mean by greatest integer? Okay, how to find that, and how is its graph, and what is the domain to this function, and what is the range? Domain is input, range is output. Yeah. And signum function, it is from modulus function only again, but small algebra is there, that's it. Okay, no? Then we have exponential function, logarithmic function, okay, fractional part function. After that, we have taken the limit definition. What is the limit of a function means? Suppose if the variable is approaching to certain value, then for that value of the variable, function approaches what value? For example, limit, if you write anything, what is the meaning of limit x tends to 3, x square plus 4 means when x is approaching 3, x square plus 4 approaching what? That is called limit. That's it. Okay. So this approaches what? Tell me, friends. 9 plus 4 is equal to 13. So that is called limit of this function. If I take this is the function, then function is approaching to 13. When variable x is approaching to a number 3, the function is approaching to number 13. Clear or not?
Yes, sir.
Yes.
So this is what basic definition of limit. But here again, it's approaching 3. And from which direction? It's from left of 3 or right of 3, based on that LHL and RHL. But every time LHL, RHL calculation not needed, right? For standard functions and algebraic functions, LHL, RHL, until and unless if they give different functions for different values, no need to use the LHL and RHL. But whereas standard functions like trigonometry, fractional part function, greatest integer function, for all these things, even though they don't mention in the question, we need to follow left hand limit and the right hand limit. Okay, no? So here we have a definition of what is left hand limit to a function at a variable x, and what is the right hand limit. Both is there. And when a limit to a function exists means LHL and RHL are equal, limit exists, right? And limit does not exist under what condition? And what is the meaning of does not exist in mathematics, right? Suppose any question, it is ending up with this after substitution or after simplifying, then we can say that it does not exist. Then we will try to apply the concept of limit to avoid this type of situation. Yeah, for example, we have that limit x tends to 2, x minus 2 into x minus 3. If you substitute x tends to 2, it is in the form of 0 by 0. That's why first we need to eliminate that. For that, what we are doing, that factorization or different approaches are there. Okay, no? And here we have algebra of limit, students. Algebra of limit. Limit of function means individually you cannot limit, even subtraction also, multiplication, constant, division, composition here. Here, composition means function of function. Function of function. How the limit is applicable, and how to take a limit of a rational means reciprocal, where f of x is not equal to 0, and root also we can go for the limit under the only to the function. So here we have the questions in algebra of limits. Directly, if you substitute x tends to 1, it is in the form of 0 by 0. That's why we need some manipulation here to simplify the function. And I said already, students, I hope remember also all of you, we have to remove this part. Like x tends to 0 means that x minus a or x minus root a, that function we have to eliminate. If we eliminate, no, then the situation of 0 by 0 getting cancelled. See, why 0 by 0 coming over here, tell me? Because there is an x minus 1 in both the places. That's the reason. So we try to eliminate that by taking common and cancelling. Then here that situation got eliminated. Now substituted limit and we got the answer. So that is what about algebra of limits. Is this okay or anything you need to solve, students, on this model?
No, sir, it's clear.
Okay. All of you, please check it once. Okay, different questions, which and all already we did in the just before the term exam in the class only. So again, here it is in the form of 0 by 0. So we try to take x minus 2 common. How x minus 2 possible to take common from both numerator and denominator means by taking x square common first. Now cancel the term so that it is into the normal form. When we substitute, we got the answer. So here also rationalizing. So LCM here rationalize. Here also rationalize. It's also rational. It is double rationalizing. Ninth one, double rationalizing. Yeah, here model 2. Here in this model 2, here it's good concept, students. I don't know for all of you remember. Function is defined for two different cases.
Yeah.
Then we need to discuss limit of a function at minus 1. At minus 1 means I'm going to check in the neighborhood of minus 1. Neighborhood of minus 1 means minus 0.99 to minus 0.001 roughly. Roughly I'm writing these numbers. Okay. Na? So during this range, the function is going to be fixed only because your x value is ranging from where to where? Minus 0.99 to minus 1.01. That means it's less than 0. You know?
Yes, sir.
Entire range, the function is going to less than 0. Less than 0 means what is the function? So that's why we fixed the function here and we applied the limit and got the answer. Whereas next point is limit at 0. At 0 means you are taking maybe a value less than 0 or more than 0. But less than 0 and more than 0 is different. That's why we need to calculate LHL and RHL. LHL and RHL. So how we calculated LHL, RHL also we can observe. Whereas again here I'm talking about limit extends to 1. Limit extends to 1 means we are discussing the limit of a function in the neighborhood of 1. Neighborhood of 1 means 0.999 to 1.111 or 000 like that, whatever it is. So in the neighborhood of 1 means it's more than 0, no? More than 0 means the function remains fixed here, not changing. That's why there is no need of LHL and RHL in the third case, whereas in the second case it is needed. And what is the reason? I'm explaining. I hope all of you clear about
Yes.
this. Students, all of you?
Yes, sir.
Okay. Remaining also, please respond at least in the new year. Okay, no? After writing term exam, not only in one subject, in all subjects, increase the interactions. That's only multiple times I need to convey from my side. There only we are not comfortable. Okay. Second question. At 1 means more than 1 is different and less than 1 different. That's why we need to go for LHL and RHL.
Yes, sir.
Okay. At 0, either in the neighborhood of 0 you take, it is less than 1 only, whatever
Yes,
the
sir.
neighborhood of 0. And 5, it's more than 1 only, and then at the neighborhood of 5.
Yes, sir.
Okay. And even next question also, third, fourth. Then after that, we started with standard limit, students. Standard limits. Derivation also we have. Please go through this, and any doubt is there, you can discuss. Standard limit. Even derivation also we have taken, and here say explain the point here. Okay, x square minus a square, x cube minus a cube, x to the power of 4 minus a to the power of 4. Like that, I am writing the formula for x minus a to the power of n, and I substitute it. Why I am doing all these things? Directly, if you substitute x tends to 0, what is happening here? 0 by 0, no?
Yes, sir.
Like in the place of x, if I'm writing a, it's going to be 0 by 0, which is not, does not exist. That's the reason why we are doing the simplification. Okay. Based on that, we have the different questions on different variables. And after that, these are the 5-6 expansions to compulsorily you need to remember. Hope all of you written and learned also. If not, means please highlight this now. Today, learn all these points. Today, revise all this again. Okay, so because of these expansions, no, we are having few standard results here, students. Standard results by using those expansions. Okay, these are all not like compulsory how to by heart. It's idea based questions. Okay, then there are some trigonometry. These are the trigonometric formulas you need. The limit simplifications.
Yes, sir.
These formulas, you know, students all. Then here we discussed about sandwich theorem. So you can just go through that. What is the sandwich theorem here? Function is either equal or in between two other functions. Then actually we cannot find the limit of that middle function. But with the help of limit of left side function and right side function of that middle, like g and h, we can estimate the limit of the in between function.
Yes.
Okay, na? So that is called the sandwich theorem. Related that, we discussed here important and 6 marks 100% guarantee theorem. Okay, this theorem also I hope all of you understand. Any requirement of revision is there, you can ask. And here we got very important relation between theta, sin theta, and theta and tan theta, and sin theta and cos theta. Okay, no? We got good result here. Based on that, you can apply greatest integer function. Right, that's what based on that we have done these questions, students. Is that okay?
Yes, sir.
Yes, sir.
So from there again we got questions at G, means, advanced, multiple questions to do this. Even in last exam also you got this question. Same sin of pi cos square x by x square. So these are the different questions we did on standard limits, and that standard limits about discussion we consolidated here from the formulas 1 to 6.
Yes, sir.
Again, it's applications of those numericals for different situations. Then substitution model. Substitution model means again functioning in the form of 0 by 0. Then to eliminate that situation of being 0 by 0, we need to go for some small substitution. That substitution idea also you got here in the think 3-4 examples we have. After that, what we discussed is infinite limits. While solving infinite limits, one thing you need to do is you need to take maximum powers of the variable common. Okay, maximum powers of the variable common. Yeah. Then we got here various examples. Then after that, Newton's Leibniz rule. That is, if a value is there between 0 to 1, between -1 to 1, if you raise that powers to the higher range, the value increasing. Finally, for bigger values, it's going to be very
It
small.
approaches.
Very small means it approaches 0. So based on that, we got these two questions, very important. Okay. And again, these numericals are all from practicing from material.
Yes, sir.
Just to go through, even in practicing also, we are going to concentrate on these only. This is again good question, but most of you have done mistake in the exam that they've changed the sign from plus to minus, but most of you have done mistake. I don't think there is a point to make the mistake. Please check it, students. That's why only related that we have sent even worksheet also. Have you seen anybody post the worksheet? Yesterday and day before yesterday, I posted some files regarding assignment. Those assignments are framed based on your majority of you where you made the mistakes, from those concepts and those questions related and that model they have given for branch wise to prepare those questions, and we prepared and submitted. I hope all of you got it.
Yes, sir.
Okay. The second question from material. I hope clear, students. We have just written in like normal quadratic, and we try to apply that formula of limits. Limit x tends to a, x power n minus a power n upon x minus a. Yeah. So based on that, all these numericals we have. Okay.
Yes.
So we discussed until these points from the limits chapter, students. Anything in this discussion, any point you want me to revise again, please check. I'll revise that. Otherwise, I'll continue with the next concept, student. Okay, you have even notebook also, right? Just go through the subtopic. Anything you want me to do it again, then I'll do it. Otherwise, I'll continue with the next topic. Any student, any subtopic you want me to teach again?
No, sir.
All of you, please check once and tell me. Students, shall I continue?
Yes, sir.
Yes, sir.
Okay. So now I'm continuing with the exponential limits. Okay. See, in these exponential limits, that is a function to the power of function will be there. Okay, na? We'll apply the limit to the function. Suppose if this if limit exists, then that itself is the answer. No problem. Okay, na?
Yes.
Is that okay, students? If it is not existing means, then other possibility does not exist. When it does not exist, tell me, students, this type of values. That means you have one base and power you have, right? When that possibilities may come like under does not exist case.
0 power 0. Infinity
Okay.
power 0.
What one case, another
Infinity
case?
power 0.
I'm coming back to does not exist cases, students.
So 1 power infinity is also there.
See, what are all the does not? What are all, what you may get over here? Tell me. Does not exist. You may get these two, no, students.
Even
Yes.
infinity power 0, sir.
Okay, okay. So now our discussion will be about these two situations. We handled this, we handled this, we handled even up to now this. Yes or no, students?
Yes, sir.
Now we are going to discuss about this. How to handle if it is in that situation, how to handle. Got it?
Yes, sir.
So that means if it is in the form of 0 power 0 or 1 power infinity, then how to handle. Regarding that, we have the different methods. My point clear, no, students?
Yes, sir.
Okay. Suppose we are having a function, example, limit x tends to 0, x square plus 2 into x minus 1. What is the answer? Suppose if you substitute limit directly. Here, no need to take LHL and RHL, right? LHL, RHL, is it required to take?
No, sir.
No. Then answer.
Minus 1.
2 power minus 1.
2 power minus 1, which is 1 by 2,
Yes, sir.
Yes.
Exist.
exist. No problem. That's what I'm saying. These type of functions, if it exists, no problem. Directly you can answer it. If it does not exist, suppose it is in the form of 0 by 0, what to do? That is next one. Is that okay, students?
Yes, sir.
Type 1. Suppose to a f of x to the power of g of x. I am substituting the limits over here. It is in the form of 0 power 0. It is in the form of 0 power 0. Then how to find the limit of this function? Limit. How to eliminate power? How can we eliminate the power? What is the idea of eliminating power? Students, what is the idea of eliminating power? Eliminating means what we are going to do? Tell me. The power, whichever is there on the top, no, the function that we have to
Take to 0.
make it somewhere, like, we need to maybe like a multiple we can write, like whatever it is. Which function allows you to do that operation?
the loss function.
Yes, correct. Log function. You know it. That's what I'm waiting. Take log on both sides. Log L to the base E. Okay, na?
Yes, sir.
And here also. And the log
Yes.
of f of x to the power of g of x to the base. Even see log, if I write inside function of function, I have given one formula, student, beginning. What is the f of g of x limit? Tell me what I have written. F of this, I have written like this, right? Function of function.
Yes, sir.
Same thing I am doing now. So log L to the base E equal to of something like the power, if it is, what you can write the next step.
A log E.
All of you know this point, students. K log A to the base E. So limit extends to A. You can write this as g of x into log of f of x to the base E. You can write now, students. Please check once. Is that clear or not?
Yes.
Just applying log here. Applying log student here.
Yes, sir.
Just selecting the examples. Okay. Then I need L, right, limit here.
Yes, sir.
There is a form changing, no, students? Logarithmic form and exponential form. Form changing is there, right? A power x equal to m means what you can write here? Log m to the base a equal to x, no?
Yes.
You can apply that form and get L, right? We need L, no? So log L to the base e equal to, this is all one function, like limit extends to a g of x log of f of x. You can just assume this like this. Okay, na? Like this we can assume. Then you can revert it, no? See, a power x equal to m only, right? Like see, 2 cube equal.
Yes.
Then in the logarithm, what you can write, tell me, students? Log 8 to the base 2 equal to 3. That means this power that equal to that only, no, logarithm form and exponential form. Remember this idea, students? I am keep on writing this whenever log is coming. Now in the same way, limit logarithm is here. Then what you can write? In this way you can write.
So E
So L equal to power. In that way, we will find the limit value when it is in the form of that. Okay. Okay. Write down now. Type 2. This is one model. Numericals you will take and solve it. Okay. Please note down. Clear or not above point? In the logarithm only you may find difficult. Otherwise, it's not difficult.
Yes, sir.
another form, limit x tends to a f of x to the power of g of x. When you substitute the limit, if it is in the form of 1 power infinity. Next thing is, if it is in the form 1 power infinity. So how to evaluate this function? Again, here also you need to take logarithm and the same procedure, but that 1 it is becoming no. So to make it 0, we'll subtract like above. That is L equal to e power limit x tends to a f of x minus 1 into g of x. We are applying. Please remember these two forms, students, whenever exponential limits comes. Two methods. Exponential limits comes means two methods. Okay, no?
Yes, sir.
Because see, the major background to have these formulas is log of 1 plus x divided by x. I have given this. You can check it, is 1. You can check it. I have given this formula, students, in the standard limits beginning. That is actually the main point here.
Yes, sir.
So now examples we are taking, and you have to be thorough with the concept now. Please listen, all of you. Suppose there is a limit x tends to infinity 1 plus 2 by x whole power x. Tell me now, if x tends to infinity, what happened to this value? 1 plus
2 by infinity was
2 by infinity is how much?
full power.
0, no?
Yes.
0. Power infinity, it is in the form of 1 power infinity, no?
Yes, sir.
Yes, sir.
So, okay, so therefore, now this is like f of x to the power of g of x. So, what is the f of x and what is f of x? You are clear.
Yes, sir.
Now, we don't know, it does not exist actually. So, that's why we are simplifying same by using this relation. F of x minus 1. What is the f of x over here? 1 plus 2 by x minus 1 into g of x. So, both getting cancelled. Then what is the limit value? Limit x tends to a 2 by x into x and x cancel. There is only 2. So, limit of this function is 2.
Yes.
Limit of this function is e power 2, like e square.
Yes.
I'll give like even few particular cases also there from this formula, students. Please note down. Write down numericals. Limit x tends to 0, 1 plus x whole power 1 by x. What is the answer? Please write up.
So this is second answer E.
Correct. Yes. What is the answer? to the second?
Infinity power 0.
Which one?
The third one. We get 1 plus infinity whole power 0.
1 second. 1 second.
What is it?
What is the second one answer?
E.
All of you are getting or not? Students, all of you are getting nonsense. and this is g of x. This is g of x and it is f of x. Then what is the same limit here? Limit x tends to 0. F of x minus 1.
1 plus x minus 1 into 4 minus
Whatever
x minus x.
x times 1 by x, which is equal to 1 is the
Yeah, yeah.
Salafi. My English is doing remaining. You not understand. Okay, so this is E you got, this is E cube you got, E power lambda, extra C power lambda. You are observing students, if I am taking here,
It's the coefficient of x.
okay. Look up numericals here, please write up. Limit to 0, 1 plus sin x to 2 power cot x. Do it, all answers. All same method. All this, they are following the same method.
So e power
How cos x?
so cos x is 0 to e power 2.
See this one again, it is in the form of 1 power. So therefore, how we are going to answer?
Limit e power limit x to 0. 1 plus sin x minus 1 into 2 cos x by sin x.
Okay, so it is limit extends to 0.
Sin x into 2 cos x by sin x. Sin x is cancelled. Cos 0 is nothing but 1 since e power 2.
Square is answer.
Yes, sir.
Next. Yeah. In Narayana College. నేను ఫోన్ చేస్తాను సార్ క్లాస్లో. Yeah. What about next question?
Sir.
No. No, not 1. Why? If you substitute 1 here, listen here students. If you substitute 1, it is log 3 to the base 3. You know very well, log a to the base is 1, no?
1.
A is not equal to 0.
Yes.
Right? All of you know this, students.
Yes, sir.
So it is in the form of, and for log 3 to any base is what here again? Because we need to check now it is in which form. following it or not, all of you?
Yes, sir.
In which form? So for that, what I'm doing first is limit extends to 1. I'm breaking up this. What is log AB? Maybe if anyone not able to find the logarithm questions comfortable means you have to revise the concepts
Okay.
related. Yes. So I'm writing this log 3 to the base 3 plus log x to the base 3 upon log 3 to the base x.
Yes, sir.
Next, in the logarithms, we have formula students log a to the base a is 1 when a is not equal to 0 and greater than 0. Okay, na?
Yes, sir.
And even the base should not be 1, that is one more. If base is 1, what happened? Log 1 will become what? 0. Correct? That is the next formula you are having. Log 1 to the base a is how much? You can check it. A power 0 is 1 or not. That's the reason.
Yes,
Anything power 0 is 1. That should not be 0. That's it.
yes,
Correct?
sir.
So that's what I am applying now. So limit extends to 1. It is now in the form of 1 plus log x to the base 3
Log 3. Yeah.
divided by 1 by log x to the base 3. Right now, again, I'm changing this log a to the base b is nothing but 1 by. These are all logarithm formulas only, students. Please note down. Anybody is not like done it actually before. This is the formula, right? I am applying, means I applied same formula over here.
Yes, sir.
Now if you substitute 1 more students, it is in the form of 1 plus 0 to the power of 1 by 0.
Yeah.
Why 0? I am writing log 1 to any base it is 0. Log
Yes,
1.
sir.
That's the reason. So now it is in the form of 1 power infinity only, no students.
Yes, sir.
Then what to do? What to do then? It's in the power of 1 power. E power limit extends to 1 f of x minus
4 into g of x.
Hmm.
Into log.
So e power limit extends to 1 plus 1 minus 1 cancel. 1 only left, no?
Yes, sir.
Then answer is e, right?
Yes, sir.
Next. Students, please observe. Little bit I'll increase the like variety questions over here. I'll give around 20 from this model. So please concentrate, all of you. What is this limit? First, what you need to do, tell me. First, you apply limit extends to infinity x plus 5 by x minus 5. Limit extends to infinity x. Like this, you can do first. Then what answer it is giving? Limit at infinity, what I said, if you really remember, what I said at limit at infinity. What I said, one word. I have power common, yes or no? All of you students, maximum power, I asked you to take common. If you take maximum power available common, then you are getting this answer. And here, if you substitute limit as the place of x infinity is infinity. Okay. Now your answer is going to be what? If you substitute x tends to infinity, what is 5 by infinity 0 and 1 by infinity 0? It is 1
Zero.
power.
1 by 1.
So that's why we need to apply the formula of that. It is an f of x and this is the g of x and its related formula we have to follow now. So what is the formula related to this? E power limit x tends to infinity f of x. F of x. This is the f of x. F of x minus 1. F of x minus 1 into g of x. Students, all of you getting it or not? What is the f of x? What is g of x? Only one is responding, remaining, I don't know, following or not understanding only, I don't know. X plus 5 minus x plus 1. Both cancel into x then e power limit x tends to infinity 6x upon x minus 1. Again, how to simplify this limit? Here, no problem with e by this limit again. It's in the form of infinity by infinity or not?
Yes, sir.
Now, how to simplify? Infinite limits, what is the point I said that multiple times? I am asking.
It's common.
Taking maximum powers common. Why you are not saying that word?
6 by
Maximum powers we are taking common.
Yes,
That's it.
sir.
So what is left now after taking common and cancelling? 1 minus 0. One thing, all of you who don't know this, please note down. 1 by infinity 0. 2 by infinity is also 0. If you divide 1 with very big number, like some 1 crore, what we are going to get 0.000. Small number or not? That's it.
Yes, sir.
This is all basic point I discussed one day in the class. So now what is the answer to this question? E power 6. Right. Still all are not responding. You have to be more accurate. Next question I'll ask anyone now. You have to speak and you have to tell. Be ready. Yeah, breathe, please. Breathe. Breathe over line. Is this one? Yeah, breathe over line. Press one. Student, is my voice clear? Kavish, please respond now.
Yes.
Yeah. How is it? Tell me how to do this question. What's your idea? Yeah. First you have to see to know that it is in form. Okay. First apply the limit to the base function and apply the limit to the power function separately now. So that you will come to know it comes under which model, because we are discussing two cases. Right. Then how to simplify this limit now? This limit.
We take the highest power of x out, so it will become limit x tends to infinity, x bracket 3 minus by x bracket close divided by x 3 minus 2 by x bracket close.
Good. Here, limit x tends to infinity. There only we have x at one place only. You cannot take. Correct. So it will become infinity by 3. Correct now?
Yes, sir.
Okay. Now tell me what will be the value if I substitute limit. I cancel x and x. Why we are taking infinity common without x we are taking common without taking, why can't we do? What's the reason?
To simplify.
No, ma. If you don't take like that common, it is in the form of infinity by infinity, which we don't know actually. Infinity by infinity, we don't know. That's why only to eliminate that does not exist situation, we are manipulating function.
Yes.
Okay. Now tell me what is the answer.
The
3? No, you substitute limit now here. What will be the answer? Tell me, ma. 3 minus
4 by infinity.
What is 4 by infinity?
0.
Why you are waiting this much time? Then how you are understanding? Ma? Here, of course, I'm writing here.
I got
value. Okay. 5 by 0 is 5 by infinity. I'm writing 0 only, no? And not only that, many cases I'm writing that part. See here, I'm writing.
Yes.
Then now why you are waiting for that? 0 divided by 3 plus 0 whole power. Infinity by 3 is how much? No? Infinity is a very bigger number. Big number. That big number by 3 means that is also a big number only, no?
Yes, sir.
Okay. Now this is 1 power infinity or not?
Yes.
So now we need to apply method. What is the method you need to apply? Suppose when you substitute limit x tends to a, and if it is in the form of exponential function, f of x to the power of g of x is in the form of, I have given a case to you over here, that is, that limit is nothing but e power limit x tends to a f of x minus 1 into g of x. Correct?
Yes, sir.
That approach you tell me now for this function. What is the L value? So L equal to e power
limit x to the power x tends to
infinity. F of x. What is f of x? F of x. Got it?
3x plus 4 divided by 3x plus 2
Hmm.
1 into
Hmm.
x by 3.
Okay, right now. Then L equal to e power limit x tends to infinity. Take LCM here. LCM is 3x plus 2. Now 3x minus 4 minus 3x minus 2. I'm just taking LCM here divided by x plus 1 by 3. Students, all of you following? 3x cancel. Limit x tends to infinity. Minus 6 upon 3x plus 2 into x plus 1 upon 3. And now again, we are substituting limit at infinity. We are having two places, what is that, x. So it's actually again infinity by infinity. But how to evaluate that
So
situation?
you can take x common.
Again, maximum powers, what are all available in question, we need to take common. Following or not, students, all of you? So L equal to, okay?
Is the answer e power minus 2 by 3?
Yes, sir, I got the same thing.
1 second, mode is not responding. Yeah. So L equal to e power x tends to infinity minus 6 into x you are taking common by x divided by x again we are taking common 3 plus 2 by x into 3. Now x and x getting cancelled and we eliminated that situation.
Yes, sir.
Now if you substitute x tends to infinity, it is 1 by infinity, 0. 1 plus 0, 1. 1 into minus 6, minus 6.
Minus 6 divided
3 into 3, 9. 3 into 3, 9. Why only 3? Because 2 by infinity is again 0. 2 by, that's why I'm not writing 3 plus 0, 3. 3 into 3, 9. Now which is e power
Minus 2 by 3.
minus 2 by 3. So that is the answer. Clear, right, students, all of you?
Yes, sir.
Okay. Please note down. To apply a method, we need a reason here. Right, we have the reason also. Next, this question, try once. I'll wait for your reply. First, check it. What is it? Is it in that form? Then only we have to apply. Otherwise, no need, right?
Yes, sir.
For every exponential limit, you no need to apply this
1
method
by
only.
2,
1 by 2 whole power.
1.
Answer.
That's a 1 by 2.
That's it. Over. Okay, na? Students, all of you. When we need to follow this method of doing this limit, log and all,
When
that
it's not
method,
existing.
yes, given, but here it's existing. Next. If you start solving, no doubt, it's a simple concept.
Sir, 3 by 4 whole power infinity.
Three by four.
Whole power infinity.
What is 3 by 4 whole power infinity?
Sir, it will be 0.
0. Why? I gave one formula. Do you
Yes,
remember?
sir. A power n becomes
Hmm.
0. If A is
N tends to infinity. If you raise anything to higher power, that is 0 when that number is between minus 1 to 1. Correct or not?
1. Yes, sir.
Yeah. Suppose 3 by 4. Once if you take, it is 3 by 4. No problem. But if you take 3 by 4 whole square, then it is becoming 9 by
9
6.
by 16.
3 by 4 whole cube,
27
if you
by
take, it is 27 by 60. Slowly what happens, students? The denominator is rising than numerator. So this value is going to become slowly very small and negligible value. So what is the answer to this?
0.
0. To this, what is the answer? 1 by 2. Now, what about this question? If you substitute x tends to 0 plus means You are not supposed to take negative values. So therefore, this is tan 0. It's in the form of 1 power infinity or not?
Yes, sir.
Now we have to apply that method, what we discussed now for the 1 power infinity. That method only you need to follow. Is it clear, students, all of you?
Yes, sir.
Yes, sir.
Says the 13th one e power 1 by 2.
1 second. Hello? Sorry. Okay. మనకి టోటల్గా 5 plus 4 9 సెక్షన్స్ ఉన్నాయి సార్. స్ట్రెంత్ అవును సార్, అవును సార్. 242, 190, 432 strength sir present. 32 sir, 432. That is 432 sir, plus 1 plus 2 కలిపి. ఇప్పుడు మనకి ఇక్కడ క్యాంపస్కి మనం జూనియర్ని పిలవట్లేదు సార్, సీనియర్స్ని పిలుస్తున్నాము. 150 మెంబర్స్ వస్తున్నారు సార్. అవును సార్. ఇస్తాం. జనవరి 5th నుంచి మనం స్టార్ట్ చేసాం సార్. అవును. ఇస్తాం సార్, క్లాస్ ఉంది ఇక్కడ ఇస్తాం. What is the answer to this question, students? It's in the form of 1 power infinity.
The 13th answer I got e power 1 by 2.
E power?
1 by 2.
E power 1 by 2, correct. It's in the form of 1 power infinity. So therefore its limit equal to e power limit extends to 0 plus
1 plus and square under root x.
1 and minus 1 cancel.
Minus 1 divided by 2x. So we can take it as tan under root x divided by under root x into tan under root x divided by under root x into 1 by 2.
No, like this we can write now.
Yes, sir. So, tan.
That's it. Then this is 1, right? We know that tan x by x is 1.
Yes, sir.
1 into 1 by 2, 1 by 2. Oh, why meaning not quickly responding? Yes, Arshad or yeah, Arshad, respond. Or Rishikesh or Arshad, please respond. Anyone? Arshad or Rishikesh, please respond. What about next question answer?
Sir, I got E square, sir.
You got
E square.
E square. Yeah, correct. No? What about 15th? Anybody? 14th E square, correct?
So can you want solve the 14th one?
Okay. 14th one, if you substitute limit, no, what is a to the power of 0? 1, 1, 1 by 3 whole power. That is 1 power infinity.
14th one, sir.
What is the problem in 14th? It's easy only now. Tan A plus B formula, if you know, you can answer.
Yeah,
It is in the form of 1 power infinity. So then
Yes,
E
sir.
is limit extends to 0, f of x minus 1. Tan x minus 1
Yes.
into 1 by x.
1 by x. Okay, sir.
What is tan A plus B formula?
Tan A plus tan B by 1 minus tan A into tan B.
Apply that, you will get simplification. Tan 45 is 1, no?
Yes, sir.
1 plus tan x divided by 1 minus tan x.
Yes, sir.
Then take LCM.
Yes, sir.
We'll get the answer. E power 2, right?
Yes, sir.
Yes, sir.
Okay. Remaining. 15th question also. It's in the form of 1 power infinity. Very good question it is. Very important also. 1 power infinity. So therefore its limit extends to 0. F of x minus 1 into g of x. F of x minus 1 into g of x. Then this is e power limit extends to 0. A power x plus b power x plus c power x minus 3 by 3 into 1 by x. But to continue this formula, compulsory you need to break up like this. Okay.
Yes.
Then here e power limit extends to 0. You can write this as a power x minus 1 by x, as b power x minus 1 by x, plus c power x minus 1 by x into 1 by. Then what is the formula of this? You have to revise the notes. Today, all of you do that first work. Okay? Complete revision of limits notes, whatever you have taken. What is the answer to this? Limit extends to 0, a power x minus 1 by x. You can check at standard limits. Without knowing that, no one in the class don't know means very bad. You can check in notes and reply.
Log A base E.
Why no one learned log a to the base c? The next one is log b to the base c. Next one is log c to the base c into 1 by 3.
That log E.
So you can write this as log a b c into 1 by 3. Again, again you can write this as e power log ABC whole power 1 by 3 to the base.
Yes, sir.
Power I'm taking over here.
Yes.
And here formula to you, I don't know how far all of you remember. Here same base means answer is just f of x in the logarithms. So now the answer is ABC power. That's it. ABC power or by 2. Very important procedure, and here breaking the function from here to here. Then this formula. First revise the notes because tomorrow I'm going to continue the same numericals further. Before that, you need to revise the notes and all standard formulas. I will ask tomorrow for first 15-20 minutes. With each one of you will interact. Who are going to respond to me in the class, those only stay. Otherwise, you can leave the class. No need to attend. Okay. Even after this many days, also when you ask, you are not responding in the class, it's not good. Tomorrow, I'll ask maybe entire class. It's taken to just to cross check the formulas. Also, no problem. But 100%, I want that all of you to revise the notes from beginning. You have these notes with you. Revise.
Yes, sir.
Okay, no? Please revise all formulas from beginning. All these limits related only, not like normal. This in between we did term also, not that limits related. Everything, please revise once again.
Yes, sir.
We have notes also. Tomorrow I'll ask one by one. Please respond and reply in the class.
Thank you, sir.
Thank you, sir.
Thank you.